So here we're going to determine domain and range looking at graphs. What we want to keep in mind that domain is referring to x and range is referring to y. So for this first example here, what we can see is that we have these specific points where our function's defined. With that, our domain and range is going to be just a set of numbers. We're just going to list the numbers out. So if domain is all about x, then what we want is this set of our x coordinates. So what I would do is just go through all of the coordinates. So we have a -3, -1, +2, +5. And I would just list those numbers. -3, -1, 2, 5. So there's our domain. So something that this shows is, and I'll show domain in red here, domain occurs along the x-axis. Just like we were saying, these are x values. So it's all about these locations on the x-axis where our values occur. Range is going to be all about the y values. So as you can imagine, I'm going to grab the y coordinate. So like we'll have it's valued -3, -2, and notice that -2 shows up twice, but in terms of a set of numbers, we only need to list it once. We don't need to list it both times. And then we can also see this y value of +4. So with that, if I bring this to the y-axis, I can see the spots on the y-axis where I'm defined, and that's what we want to make a set of numbers for. We have -3, -2, and +4. So when we just have points like this is how we'd write domain and range. It's just a set of values using the x and y coordinates, and then you don't need to list repeats. The more common way of how we'll be seeing functions is like this next example here. Here we have a line being graphed, so I want to set up my domain and range. Now, just like everything with algebra, a lot of different ways to think about it. If you have a method that works best for you, use it. I'll just describe how I think of it. And what I do is I focus on the axes. So if I'm working with domain, I focus on my x-axis. And I think of this kind of scan, like I'm scanning from left to right. So if I imagine I'm starting over here at -infinity and walking along, what I could see is I don't have a function to map to. I don't have anything. So in that region, my function isn't defined. So that wouldn't be part of my domain, because the domain is all about the possible x values. But what I could see is as soon as I hit -3 as I'm walking along, now my function's defined. So I'm actually going to mark that on my number line here, in that at -3, I'll put a solid circle to match what I'm seeing on the graph. Our x values are defined at -3. And as I walk along, as I keep going to the right-hand side, I'm going to have my function defined for all of those values, and going, until I hit +4. So it's like in terms of a number line, if I just squish this to the axis, the x-axis, it's defined, until I get to +4 where we have an open circle. So it's like we're defined up until 3.9999999. I couldn't graph a coordinate, but at 4, the function's no longer defined. So in making the domain, I want to express this in interval notation, which is what we practiced in that last video. I want an interval to show that I'm defined from -3 and including -3 up until 4, but not including 4. So my domain starts at -3 with a square bracket and goes up to 4 with parentheses. Now for range, I'm going to do the same exact thing, but focusing on the y-axis. So again, I'm going to think about starting at -infinity and walking up to +infinity along the y-axis. And what I can see is my function isn't defined until I get to -4. Then I have something to graph. And -3, -2, defined, until I get to +2, where I reach that open circle. Because if I'm standing at 3, I don't have a y value to graph to. So for range, I'm thinking about how my graph starts at y equals -4 and including -4, and then it's defined all the way up until +2, but not including +2. So now what I want for range is an interval that describes my graph right there, starting at -4 and including it, and going up to 2, but not including the endpoint of 2. So my range would go from -4 to +2. So that's one way of thinking about domain and range. Again, a lot of other ways to think about it, but I think squishing it to the x-axis and the y-axis can help in terms of the visual. All right, domain. So if I think about starting at -infinity, what I can see is if I'm out at -infinity, I have something to graph to. This is going to go on forever and ever and ever out to -infinity. And then as I go along the x-axis, I have values that I can graph all the way out to +infinity. So what I can see is that my function for x is defined everywhere. So my domain is going to be all real numbers, which you can write as a sentence, or you can use that symbol that we talked about with the fancy R, the 2 lines, that represents all real numbers. That's the same thing. In interval notation, I would express this as -infinity up to +infinity. So 3 ways to express the same thing there. You only need to write one of them. You don't need to write all 3. I just want to make sure you have all the notation. Now for range, I'm going to think about the y-axis. And what I could see is like if I'm here at -3, I don't have any function being graphed until I get to -2. So at -2, my function starts. And then as I go up, I have my function, and then if this is going off to +infinity, so is the range. So what's going to happen is my range is going to start at -2 and including -2, since we're going to be defined there, and then it's just going to go off to +infinity. So in interval notation, I would have a start at -2 with a square bracket, and then go off to +infinity. Alright, piecewise graph here, or step graph, for my x values. So I'm going to walk along the x-axis. What I can see is out here, I don't have anything for my function, nothing, until I get to -2. See, I was using red, and I have a solid circle there, so I'll represent it with a solid circle there. So then I can see I have my function, At 2, I'm going to pause for a second because I see that hole up above there, so I might be tempted to make a hole at +2. However, we can see there's actually a coordinate defined there. So because we're defined somewhere in only one location, we'd actually just keep graphing past 2 since it is defined there. And we keep going and going and going until we get to +8, which would be the end of our function. So we can have x values all the way from -2 to +8. So I'm going to write that as -2 with a square bracket up to 8 with a square bracket. Now for range, if I'm walking along the y-axis, I've got nothing, and then at -2, and just at -2, I have some values being defined. But it's only at that one location at -2 if I'm just thinking about the y-axis. Even though there are multiple x values, for all of those coordinates there's a single y value. And then I've got nothing, until I get to +3, where I have all different x values, but this same y coordinate of 3 across all of them. So that's also going to show up as a point at +3. So this is kind of like our first example, where the values are only happening in very specific locations. So with that, we're going to create a set of numbers. So I'm going to use the set notation and say -2 and +3. So with that set notation, I realize it's not an interval, it's just these specific locations. All right, let's look at two more examples here. This is going to be our rational function, which we'll talk about a lot more. But what we can notice is if we go along the x-axis, I have my function, I'm defined, and then there's going to be this spot. In fact, I'll draw a line for it right here. It's called a vertical asymptote. The idea is that our graph gets infinitely close to it, but never crosses it on either side. We're going to get super close, but never cross it. So what that's going to look like for our domain is that we'll be defined absolutely everywhere except for right at that vertical asymptote, which is occurring at +2. So this idea is that we can have all real numbers and x can't equal +2. So we saw this in an example in the last video, so you could write this in words. In fact, I'm going to use the notation with the R. So it'd be all real numbers and x can't be +2 would be one way to write that. If we wanted to use interval notation, we would say we're going from -infinity up to 2 but not including 2, and then with a union of starting at 2 but not including 2 off to +infinity. For the range, we're going to see a similar thing happening because we have a horizontal asymptote as well. So if I'm going along the y-axis, it's defined until I get to +1, where there's going to be this hole where we're not going to have our function defined. It's going to get infinitely close to it, but never actually cross that line. And then we can have everything above it. So, same idea, except now we're dealing with y equals 1. So for range, I could say all real numbers, and y cannot equal +1. Or we can say for an interval, we're going from -infinity to +1, the union of starting at 1 and going off to +infinity. So these asymptotes are going to be something that pop up with rational equations. In fact, let me name this up above here. So with our rational functions, which we'll have a lot more practice with later in the term, and a little bit in the next video, we're going to see these spots at these specific locations where our function is not defined. Alright, this last one, this is a radical function. So this is something dealing with a square root, it looks like. So, for our domain, our function's defined, and then it ends at x equals -3, and including -3. So for my interval notation, I want everything from -infinity up to and including -3. For the range, this is going off to -infinity, so it'll all be defined, until we get to +1 and including +1. So with this one, we'll see -infinity up until and including 1. So this is how we can look at the limitations of our domain and range based on the graph. In the next video, we're going to look at the algebra of it. We'll kind of work out some ways of calculating these values based on the function itself.